All right, let's solve some ellipses. Here's an equation that we're given, x squared over 25 plus y squared over 16 equals 1. And you should have your notes handy so you can look at the different equations for each of the elements of an ellipse and how to find them. Now, when we look at this, first of all, let's remember that the equation for an ellipse needs to be in this form. X squared over a squared plus y squared over b squared equals 1. We're currently not in that form because our 25 and our 16 are not in the squared form, but can we get them there? And you can probably see that, yeah, we can rewrite this. So let's rewrite this as x squared over 5 squared plus y squared over 4 squared, and all of that equal to 1. Now we look like the form that we can use to find our A and B and plot our vertices, our major axes, and so forth. Now, one thing to note here is that A is greater than B, which means that this will be a horizontal ellipse. It also means that our foci down here will be located along the major axis, which will be the horizontal axis in this case, the major axis. All right, now since we're in the form of x squared over a squared, we can get some information right away. If you remember, our vertices will be located at plus or minus a comma 0. Oops, let me back that up. Plus or minus a comma 0. So in our case, that will be plus or minus 5 comma 0. So let's place those out here on our graph. 1, 2, 3, 4, 5 in that direction, and then 5 in the other direction. There we go. There are our vertices, and our major axis will lie along that. So our major axis, which is for horizontal ellipse 2a, will be 10 because it's 2 times 5. And we could plot that if we wanted to. We could draw that in here. That's our major axis right there. Okay, now what about our co-vertices? Well, those are located at 0 plus or minus b, all right? Because this is, again, a horizontal ellipse, and our minor axis, our co-vertices, will be on the vertical axis of the ellipse. So those points, if we go back to our equation, b is in the position of 4, so this will be at, go back to green, 0 plus or minus 4. So let's plot those. Let's count up from the origin, 1, 2, 3, 4, and then down 1, 2, 3, 4. There we have our minor axis. And you don't need to draw the axis every time, I'm just showing you where it is on here. So the minor axis is going to be at 2b, and that will be 8 in our case. Well, with those 2 points, we have enough that we can draw an ellipse. If we had toothpicks and string like the last video that we looked at, we could also plot the foci and then draw it. But from here, we can draw the shape of an ellipse. I'll draw the top and draw the bottom. You draw this too, yours. And there we go. We have our vertices, and we'll highlight those in yellow right now. Our vertices here along the major axis, and then our co-vertices along the minor axis at those points. And to label those points, this would be negative 5, 0. This would be 5, 0. This would be 0, 4, and 0, negative 4 down at the bottom. All right, now what about the foci? The foci are located at, for a horizontal ellipse, plus or minus c, 0. But to find c, we need to use an equation. So if you remember, in the last video, we looked at the equation is c squared equals, and in our case, since a is bigger, a squared minus b squared for a horizontal ellipse. So if we plug in a squared and b squared, which are just the denominators of the x squared and y squared terms, c squared is 25 minus 16, which is 9. So that means c must equal 3. And really, in this case, plus or minus 3, which is totally true, because that's what we end up putting in our places. So let's plot those points. 1, 2, 3. Our foci will be at F1. We'll call that negative 3, 0. And F2, 1, 2, 3. That's F2 is at 3, 0. So there you go. There's an example of a horizontal ellipse. You can recognize it once we get it into the squared form, and it matches our equation right here, our standard equation, and a squared, or a is greater than b. That would mean we're flattened along the horizontal axis. All right, let's look at one more example together. All right, here's another equation, 25x squared plus 4y squared equals 100. Can you recognize if this will be horizontal or vertical just by looking at it? Now you should notice that something isn't quite right here. We need it to be in this form again. X squared over a squared plus y squared over b squared equals 1. First of all, we don't have fractions to start with. That's okay, we can make fractions, right? We can have 1. But there's also, notice there's no coefficients in our standard form right here for x or for y. The x and y terms don't have coefficients. Also, notice that when everything is equal to, the constant on the right side of the equation should be 1. But in our case, it's 100. Well, what can we do? We can divide every piece by 100. So watch what happens when we do that. When every piece gets divided by 100, let's look at the x term. 25 over 100 will reduce to x squared over 4. Then we'll have the y term will reduce to y squared over 25. And that will all be equal to 1. Notice how we now got it one step closer to that form. Now, we're not quite there yet, right? We needed to have those squared pieces. So we'll rewrite it one more time as x squared over 2 squared plus y squared over 5 squared, and all of that will equal 1. So that's the term that we're going to want to look at and use. That will be the most helpful to us as we graph. So I'll circle that over here. There we go. So what we had to do is start with the original equation. We had to divide by the constant on the right side to get it all equal to 1, and to get denominators that we then put in squared form. Now, can you notice which is bigger, A or B? You should notice that B is bigger. B is greater than A, which means that this will be a vertical ellipse. It will be aligned, the longest axis will be vertical. And in our case, since we don't have a translation, it will be along the y-axis. And that also means the foci will be situated along the y-axis. All right, so how about vertices? Let's talk about our vertices here. Since this is a vertical ellipse, we should expect our vertices to be along the y-axis. So they will be at 0 plus or minus b. Those will be our vertices. So let's plot those. B in our case is, we should just write this out, B equals 5, A equals 2. We get that from our equation right here. So if the vertices are at plus or minus 5, or 0 plus or minus 5, we start at the origin and we count up 1, 2, 3, 4, 5, and then we count down 1, 2, 3, 4, 5. All right, so there are our vertices along the major axis, and the major axis should also have the foci when we get to those. Okay, so the major axis is 2b in this case, which is 10. All right, let's look at our co-vertices. The co-vertices are located, in this case, along the x-axis. So they will be at plus or minus a, 0. So for us, that means they will be at plus or minus 2, 0. So let's plot those. We go to the origin, we count 1, 2, and then we go the other direction, 1, 2. So this will be a little narrower than our last ellipse. All right, now that's enough to draw a graph of this ellipse. And you notice this is a lot skinnier shape. This is more football shaped than the last one. Let me fix that right there. There we go. Okay, so that is the vertices. We have the major axis. The co-vertices, our minor axis, will be at 2a because this is a vertical ellipse, and a represents the x length, which is the shortest distance to cross. So 2a in our case will be 4. Now how about the foci? The foci are located, in this case, along the y-axis. So our foci will be at 0 plus or minus c. But remember, we need to find c. And I'm going to work in this space under the graph over here. So c squared equals, in our case, the bigger value between a and b is b squared. And this is vertically aligned. That's the 2b represents the major axis. So it'll be b squared minus a squared equals c squared. So make sure you have those right for vertical or for horizontal. Okay, now let's plug in our values here. So c squared will equal b squared, which is 25. So 25 minus 4, which that equals 21. Well, this doesn't work out perfectly for it, does us? That's okay, we can handle it. C is going to equal the square root of 21, which is approximately, I want to say, 4.6. So we'll go with that. We'll call it 4.6, which means our foci will be located at 0. And we can actually leave it in radical form. That's fine. Plus or minus radical 21. So that's fine for notating it when we're writing out. We can leave it in radical form, but we'll want to have an approximate value for that when we go to plot it. So our foci are going to be at approximately plus or minus 4.6. So remember, it's located along the y-axis. We start at the origin again. We count up 1, 2, 3, 4. We go a little more than halfway. And notice that the skinnier our ellipses get, and I'll count down 1, 2, 3, 4, and then a little past halfway, that the foci get spread out more and more closer to the ends of the major axis. And you can imagine if this got skinnier and skinnier, or not skinnier and skinnier, but flattened out along the y and the x stayed the same, eventually you would come to a circle. And those two foci would converge on the center of the circle, and the major minor axis would be the same, and that would be a radius. So kind of neat. You can see how this relates to a circle a little bit, and those are two great examples for you of a horizontal and a vertical ellipse. All right, we'll see you soon.